Now here we talk about what is forward propagation. Normally a forward propagation is a process in a neural network where the input is passes through the neural network to generate the output. And in forward propagation we have input layer, hidden layer and output layer. Generally a input layer feeds the data into the neural network, and in the hidden layer the data is passes through one or more hidden layers, and each neuron in the hidden layer will receive the input from its previous layer. And in the hidden layers we generally use the ReLU activation functions. And coming to the output layer, the decision of the activation function mainly depends upon the tasks, such as for binary classification we use sigmoid, and for multi-classification we use softmax, and for regression problems we use linear activation. Here we can see how a forward propagation works. Here I have taken x1 and x2 are the two input values, and initial weights are w1 to w6, and the target value is 1 with bias b1 and b2. Now we can see in forward propagation the h1 is equals to x1 w1 plus x2 w3 plus bias b1. So here you can see for the neuron x1 input having weight w1 and x2 input having the weight w3 is connected to h1 with bias b1. So after applying this we getting 0.535. So I have said in hidden layers we generally use ReLU activation function. So after applying the activation function of ReLU we getting output as 0.535. Similarly we find the value of H2 with inputs x1 and x2 with weights w2 and w4 and with bias b1. The equation will become x1 w2 plus x2 w4 plus b1 and getting as 0.55, and we next apply the activation function ReLU and we getting output as 0.55. So in general we use the activation functions in a neural network to generate the non-linearity so that model can learn complex patterns. As I said, each neuron will receive the input from its previous layers. So the input for Y will become output of H1 with weight W5 and output of H2 with weight W6 and with bias B2. And we are substituting those values. We are getting 1.0975. As Y is the output layer, I am using sigmoid activation function. I am getting the output as 0.7497914. So after all this process I am getting this value, but actually my target value is 1. So now I have to calculate how much error I am getting. So for this I am using mean square error formula. The formula is 1 by 2 is equals to actual value minus predicted value whole square, where actual value is the target value and the predicted value is the value which I got. After substituting this I am getting the loss as 0.031302172.